Sines that we've been working with was basically the two scenarios of angle side and an angle, because you'd have that, or it was angle, angle, and a side. We're going to talk about that in a second. All right. Right now, the two different ways that we worked with law sines were those, because you were able to come up with an angle opposite a side and make everything work out okay. What happens now is that we're going to talk about what's called the ambiguous case. The ambiguous case in the law of sines is the, it could be, it might not be, it could be more than one, and it's one of those things. It's kind of, it's fuzzy. We'll call it fuzzy math. So what happens with the ambiguous case, this is your side angle stuff. What one? Well, this is the, well, this angle, if you look at side angle side, that means you have an included angle. It's different. When you have this side angle side case, that's when we use law of cosines. In this case is the side angle. So you have to watch your side angle very carefully on these things. I'm an idiot. Anyway, so don't write this out. What I want you guys to understand here is usually at this point in time, there's been some things that we have discussed. We have discussed what's called radian measures. And we have discussed positives and negative values along what's called the unit circle, where sine values occur, where cosines, and all that stuff happens. What I want to do here is kind of give you this little handout as well as a little bit of something extra on the back here to kind of explain to you guys what, in essence, is really occurring with these types of scenarios. You're going to find out that there's a lot of words here for something that is ridiculously easy to work with. It always sounds a lot worse than it really is. So, let's see here. First thing I want to ask you is, oh, this is annoying trying to count. How many degrees are in a triangle? All right, so we all understand there's 180 degrees in a triangle. You're going to be just fine. Here's what happens. And this is kind of going forward where we're not at quite yet, but I'm going to kind of introduce you guys values of sine. What's that?
Coordinate plane.
Coordinate plane, okay? If I start here, I call that 0 degrees, 90 degrees, 180 degrees, 270 degrees. You okay with that? Okay.
Oh man,
Oh, it doesn't.
You can't do this, yeah. We okay on that? Now, what happens here is your x and y values in the first quadrant, they're both positive, correct? In the second quadrant, they are negative and positive. Here they're negative and negative, and here they are positive and negative. As we develop more and more into this unit, you're going to learn about the xy coordinates in terms of sines and cosines. What happens here is that your sine values start to play the role of the y coordinate in an xy3. So that tells me that my sine values are positive between the first and the second quadrants, which means that there's always a positive value of sine for any angle between 0 and 180 degrees. Does that make sense? No. Type in your calculator sine of 60.
Yeah. Isn't it always the same thing? Well, I mean, well, okay, I don't know why I just said that.
Is it positive or negative? Type in the sine of 120.
It's the same thing.
It's the same thing, isn't it?
Why?
Why?
Oh, because you multiply by 2, right?
Here's what's happening. Let me explain this real fast. We're going to get into a lot of the rationale behind why this works next week. It's easier to explain just a little bit of it now because it alleviates all this junk on your sheet of paper I gave you. here's what happens. When you have a 60-degree angle, you had a sine value of 1/2, correct?
Yeah.
Now, what happens is, that's 60 degrees up off the axis. You agree with me on that?
Yes.
Now, if I go to the other quadrant over here, to the second quadrant, does my y value change if I stay horizontal there? No. If I make this a 60-degree angle coming up this way, isn't that still the same angle? Which means that, oops, let me move this down here so it looks like it matches up. Which means that the y value here doesn't change. What changes is the x value. The x value becomes negative. Okay? So these two values share the exact same sine value in two different quadrants. Okay? So what this is called a reference angle, coming up off of 180 degrees. Which means that the full angle is how much? 120. It's the mirror of it. There's symmetry. If you think about it, they fold in on one another, and then you wind up with the same stuff. It just happens to be in a different quadrant. Okay. Now, what happens here is that you can deal with what are called reference angles and bounce things within quadrants. But a very easy thing to understand is when you're working with law of sines, there is a possibility of having two different angles that have the same exact value for sine. And that's where this ambiguous stuff comes into play. You've never had to really worry about that before because we just kind of say, here, just do this and it works. What's going to happen now is that we're going to give you a problem that might not exactly work. You might get two different triangles out of it because you could have two different angles with the same value. Okay? But it's very easy to work with because how many degrees are in a triangle? As long as you keep that in the back of your mind, this is easy. Okay? Let me show you an example. What they're doing here on this sheet of paper is showing you all the different types of scenarios that you can come across by putting in values and working through all of the, excuse me, say this real quick, telling whether or not your given angles are obtuse or acute and typing in all this different mumbo jumbo. But if you fall back into just the idea of the law of sines, which I'm going on the limb is very easy to work with, right? Or am I overstepping that?
You're a little overstepping.
Wait, what?
It's not bad.
Working with law of sines is relatively easy.
Yeah, it's
Okay.
I
So,
give it a 4.
Let me show you this. So I've got angle A is 170, side A is 155, and side C is 160. Yes, ma'am?
Did you just say that angle A is 170?
I meant 70, I'm sorry. Thank you.
Yeah,
Sorry,
Wait.
I was looking at all the other hundreds I had up there.
That's more than 100.
You got hundreds everywhere.
Like everywhere?
You got hundreds.
That's side lines.
Oh, okay. I thought the C was the big.
Move it to
Sorry.
side.
Okay.
Draw it out. We know that angle A is 70 degrees, side A is 155, and side C is 160. Notice this is your angle side case. So this is where you have to be careful. So when you're setting this up, this is telling you to find what angle first. Correct. It's forcing you to figure out angle C to start with. So we set up our law of sines like you would normally. So we have the sine of 70 is to 155, as the sine of angle C is to 160. Now, the question you guys had like that yesterday was to do what? Sorry, man, go ahead.
Why is it pointing us to find C and not B?
You don't have a side opposite B.
Oh, so you have to side up.
Yeah, law of sines always works with sides opposites. Okay.
Oh, that's 160.
Yeah. Remember when we did this yesterday? When you had this scenario, you just multiplied over here by 160, and then you did the inverse of the sine to find the angle. Now, when you do that, you wind up with an angle value of 75.93. Okay? Down. I multiplied by, because I was dividing by 160, so I just multiplied to the other side. Okay? So right now, I have 75.93 for the possible angle of C. We okay with that? Okay. When you're doing law of sines, and it has this angle side-side scenario, what I want you to do is the first time you find an angle, find its supplement. Sorry, I forgot what it's called. What's the supplement to that? 75.93. Take 180 and subtract the 75.93. What do you get? So you get 104.07. We'll call that C, bless you, C prime, because that's like the other possible one. So what I'm doing here is those two angles have the same sine value. Same idea of that sine of 60 and the sine of 120 have the same value. These two angles should also have the same one. So let's see here. Sine 75.93, sine 104.07. See how you're getting the exact same value for sine?
Yeah.
It's weird, and the reason that's happening is because you've got a reference angle bouncing off the x-axis that mirrors them up so that their y-coordinates in the grid are the same. Yes?
So anything that happens to the
What do you mean by anything?
like if you took 10
Should work, yes. Because they have the same reference angle.
Well, other than that.
Because 10 degrees up is the same thing as 10 degrees up here. So they have the same y value. That's what happens. Yes, Mike?
Nice.
What is that, 104?
What's happening here, and this, to go back to the idea of in the grid, 75 degrees is here. Coming up this way would be 75 degrees and change. The same, what we call the reference angle into the second quadrant would also come up 75 degrees up this way. Now, if I'm thinking in terms of between 0 and 180, going from here to here is 104.07. Because these two values are on the same horizontal line, which means they have the same y value, which means they have the same sine value. That's where this comes from. Okay? Yes, ma'am?
I need you to back up to where it's like 160 times like 70 divided by, where did the 75.93 come from?
I just typed in my calculator. Here, I'll show you.
I typed it in my calculator and it got,
Oh, you got to do it. You didn't close, did you close your parentheses?
Yes.
yeah.
Did you? Here, I'll show you.
There's negative 1 sine of whatever the other is.
Maybe
So 160 times.
Type it in exactly the way I had it written, so it's what, 160 sine something over,
Divided by 1.5, and opposite sine, the answer, and...
so what,
Oh, okay, I got it. I figured it out.
so I get 160 sine 70, enter, divided by 155, enter. And I get this decimal.
Yeah.
That equals the sine of something. Second sine of the answer. Why do I do that? Because that's, this is, that crummy decimal equals the sine of an angle. We're undoing sine by doing the inverse. Okay. That's how I'm getting the 75. Yes, ma'am?
Why do you have to find?
Because this is the possible case of having two different triangles. And this is the idea. What's that? Yes. Whenever, this is the whole idea behind the this whole angle side case, or the side angle to be politically correct, is I'm trying to show you guys an easier way of doing this instead of what they have on this sheet, okay? By doing it this method, it's a little bit cleaner than having to go through the checks and balances of all the different scenario possibilities. This takes forever. Anybody can subtract from 180. Okay.
So what is?
This is the only time you have to worry about the ambiguous cases, only when it's a given side angle. If you have angles, angle side angle or angle side, law science is just going to work. Not necessarily. This is why we check it. And I've got examples here. Guys, come on. What I did here was, this was our value of C. Guys, please. This was our first value of C that we found. Knowing that the value of an angle has a sine value that's positive in two different quadrants, I figured out what the other angle possibility is. So that's why I called it C prime. So there's two different angles that have the same sine value that are between 0 and 180 degrees. So what I want you guys to see now is, if I put 7593 in here, is there enough degrees left over to find an angle B? Yes. What would you get? 34.07. Now if I do that again with, let me just move this out of the way for a second. If I do that again with the 70 and the 104.07, are there enough degrees left for an angle B in this case? What do you get?
6.
Well,
5.93.
593? So how many possible triangles can I get off of this? 2 of them. What this allows you to be able to do is to check and see if you could create a secondary triangle with the angle B, with your leftover angle. That's what this does. Yes, ma'am? Because the calculator is only going to find it in the first quadrant. It only finds it in the first quadrant. We talk about that at the end of 13. Or beginning, sorry, middle of 13. So that's how this one cleans. This is how this one works. Yes, ma'am?
I forget, like, how like this on homework, you want to find those triangles and you want to solve them.
Yeah. Yep, and this is exactly what would wind up happening at this point, is that you would find the other side length for your angle B. Notice how you have two different possible side lengths for little b at this point? You would use law of sines then to find the two different cases. What happens in this triangle, you get obviously one that looks like the one I have drawn up in red, or you're going to get an obtuse triangle with a very skinny angle at the top there. It is totally, completely plausible for this to occur. And the reason that these things occur, if you look at this side, I thought this was a pretty cool explanation. We all agree that there are heights in every single triangle, right? Now, what happens here is your height can be found in any triangle by using sine. Because you've got a hypotenuse drawn in, so you'll have a right angle at the height. You use the sine of some angle is the height over the hypotenuse of your other side. Well, what happens is that this allows you to see that your other side lengths could be too short to touch, or long enough to create two different triangles, or be exactly the height. That's what all this junk says on this piece of paper. It's cleaner and easier to walk it through via 180 degrees is all I'm getting at. I think this is a really nice way of doing it. I've never taught it this way. I've always tried to do it this way. And this is so much nicer. Okay? Let me show you another example how this works out.
In the time when one of them went work this way and come up with a negative or something?
Yeah, exactly. It shows up very, very obvious. It's really easy to see that you're not going to get a triangle. Okay? So I have triangle ABC again. Angle C is 25, and side C is 6, and side B is 20. As you can see, this is a side-side angle scenario, because I've got two sides and a non-included angle.
Right.
Which angle is this diagram trying to force me to find first?
B.
Good. Let's set up the law of sines to find B. So we have the sine 25 is to 6 as the sine of angle B is to 20. What am I going to have to multiply out by first? 20. So in my calculator, I'll type in 20 sine 25 divided by 6. And then I'll do the inverse of that to find the angle. Let's do that. 20 sine 25. What's that? Do you want to put this back up for a second? Close it, hit enter, divided by 6, hit enter. And right now I have the sine of some angle is 1.4. Second sine of your answer you get, which means what?
It doesn't happen.
It doesn't happen, therefore,
It's
no triangle.
Oh, okay.
It's no triangle can be formed. What this means is that you're not going to be able to form a triangle with these side lengths. In essence, what it's looking at is 20, or one of these sides is going to be too short to touch the other one. It doesn't match up with the largest angle to the largest side or smallest angle to the small side. That scenario doesn't play out in this case. So it's by using the law of sines, if you come up with an error, just double check, make sure you didn't type it in wrong. It just means there's no triangle. Okay? Yeah. You can go through all those different scenarios, those 6 scenarios on your sheet. It's quicker to do it this way.
So we're going to be looking at calculator.
What's that? No. You can't do law of sines without a calculator. I mean, could, but no. That's just awful. That is absolutely awful. Okay? Let me show you another one.
You bring it up to all by what those things said.
It's good reference material.
And I put the big this is what I should start with. But then I was like, I'm just going to put over my
For me, that's so kind of you.
So let's see, triangle ABC, 60. So here we go again. Notice this is again a side-side angle scenario. So which means when you see that, you got to take your time just to double check, make sure things are going to work out. So when I set this up, which angle is it trying to get me to find first?
C.
Good. So we start with that. We get the sine of 60 is to 30, as the sine of C is to 20. By now, everybody knows that we're just going to multiply by 20 and go through the rigmarole of it, right? Rigmarole. So 20, oops, 20 sine 60? Yeah. By 30. Second sine of my answer, and hit enter. And I have 35/26. We okay on that?
Yeah.
All right. So my first possible would be 35/26. What's my other possible?
144.74.
All right, 144.74. So if I check in my original triangle, if C is 35/26, what would A have to be?
Negative. No. I was sorry, I did it backwards.
84.74.
84/74. If I do that again with the 144/74, it doesn't work, does it? Because isn't 144/74 plus 60 bigger than 180?
Yeah.
So will I have 2 triangles in this case?
You got uno.
I've got uno. Bless you. What we're doing here is we're checking with that supplement, if you will, supplementary angle of the first one you find, and checking to see if it goes. Yes, ma'am?
Oh, so this kind of goes back to the whole triangle thing.
Yeah.
I just thought of it.
So if your answer is greater than 1, is it going to be maybe?
Because you can't take a sign value that's greater than 1. Hey.
So like if this were doing more function, we have to find side A.
Yeah, then you would just finish out figuring out the rest of the triangle. What happens when you had that side-side angle case, you need to check the 2 angles first. And if you get 2 angles that would work, then you'd find 2 different sides. And then you would find, because you'd have 2 different angles. Does that make sense? Michael?
So you put 144 back in for C.
Yes.
And then you add that with what?
60.
Okay.
And notice right away it's going to be greater than 180. That's why I throw it out, because even though it does have that same sign value, since I'm given the 60 at the other angle, it won't make a triangle. Okay?
You could have just stopped when I saw like 144 and 60.
Correct. And that's exactly what I did. Okay? Does that make sense why this is only one triangle?
Yeah.
It's scary sometimes, isn't it? The only other thing I wanted to show you guys today is that you can use signs. It's not so much the law of signs, but you can use sign values to find the area. In this case here, what happens with a triangle, instead of doing 1/2 base times height, you can actually use the value of signs with given side lengths to find the areas of a triangle. It doesn't base itself off of 1/2 base times height, but here's what happens. You need to have the angle, or excuse me, you have to have a side angle side case for this to work, to find the area of a triangle. You have to have side angle side to make it work, because it's always the 2 sides and its included angle you need to have to start with to fill it out. Once you get that, it's just a matter of substituting as you go. Okay. Now they write it out in all 3 different possible ways, because you got all 3 different angles. But just remember, in order for this to work, you need side angle side. It's not to say that it won't work with angle side. You just have to find a different side, that's all. Okay. But once you get side angle side in a given triangle, you can use this scenario to set it up. And it's nothing more than taking 1/2 your 2 sides times the sine of the included angle. That's the area. It's that fast. That's all it is. The only caveat here is you've got to have side angle side in order for it to work. Okay? That's the only thing you have to have with these. Yeah, he's right. Someone gets started to sing Frankenstein. Question? You want to do another one of those law sign ones? Nah, they're too easy. Yeah, Michael. Sure. Basically, Michael, all you need to remember is that you need side angle side to make this work. If you have it, it's good to go. Okay. Because if you think about, in this case here, what is it? B is 2, C is 3, and A is 47. If you draw in this height, you're finding the sine of this angle is opposite over hypotenuse, and you're bringing it all through, and you're doing all that kind of stuff. All right. And obviously, the 2 isn't the whole section of that, but it's not part of the problem. Here's what I want you to do. This is all 13.5 stuff. Okay? So it's page 804, 28, 83, 49, 50, 57, and 58. And if you guys remember, if you honestly remember the trick that the values of sine are positive in 2 different quadrants, it's just really easy to work with, okay? Really easy. So much easier to do it this way than the other way. Questions? Get my stuff out of your way. Sorry.